Find the area of Psrq from the given figure. Line construction, Pythagoras theorem, area of right triangle, arithmetic, and algebraic operations are used to solve this question. Solution. Join line PR from right triangle PSR. Using Pythagoras theorem, the square of length PR equals the sum of the square of length PS and the square of length SR, which equals the sum of square of 3 and the square of 4. The result equals 25. Take the square root of the equation. This implies that length PR equals the square root of 25, which equals to 5. Also, consider triangle PQR, and let angle PQR be equals to theta. Using cosine rule, the square of length PR equals the sum of the square of length PQ, and the square of length QR minus 2 times the product of length PQ, and length QR multiplied by cosine theta. Substitute values. This implies theta. The square of 5 equals the sum of the square of 13, and the square of 12 minus 2 times the product of 13, and 12 multiplied by cosine theta. Solve for cosine theta. This implies that cos theta equals the sum of the square of 13, and the square of 12 minus the square of 5. All divided by 2 times the product of 13 and 12, which equals 12 divided by 13. Hence, PQR is a right-angled triangle at R, where 5, 12, 13 is a Pythagoras triple. It follows that area of green region equals half the product of length PR and length QR, minus half the product of length PS and length SR. Substitute values. We have that the area of green region equals half the product of 5 and 12 minus half the product of 3 and 4, which equals 24 square units. Therefore, area of green region equals 24 square units.